Firstly, I want to say I'm a starter, so I have a problem of articulation. So sometimes the words can't get off my, uh, so it's hard to pronounce. So I will try to get more sentence out, but I already have the pre-recorded video that in case that I can't continue to say. So I'm Rong, and I'm from the MTG in Barcelona, and I work for the Com Music project. And the presentation is about the pitch contour segmentation for Jingju singing training. So my presentation structure is I will firstly shortly introduce this background of Jingju. Then I will give a brief introduction about the professional Jingju singing. And I will talk about the special characteristics of these vocal expressions. Then I will give a web prototype that implements all these algorithm, and then I will get into the details of this approach. Then it's the evaluation, and finally I will do this conclusion. And the Jingju, also known as the Beijing Opera, is a traditional Chinese art form that which combines the singing, this mime, the dance, and the acrobatics. And this obviously the singing is the most important performing uh, uh, skills in Jingju, and there are mainly four role types in Jingju: Shen, Dan, Jing, Chou. So the first one sing a lot, and for all these role types, they have widely different singing styles. And we have been doing a 5 months research stay in the National Academy of Chinese Theater Arts to make clear the professional way of how they train these Jingju singers. So we have been found out the imitation is the main method. So yeah, at the beginning of this class, and the tutors will give a short introduction of this class content. And for example, the general stories and the characters of each role. And then the teacher will give a demonstrative saying for the whole class. And then the training will being asked by the tutors to do a tentative uh, saying. And then the tutors will give the verbal feedback or a demonstrative saying based on this tentative one. And based on this verbal feedback, and the trainings will do another revised saying. So there's a short videos to show this training process. So as you can see, this training process is not so effective because the trainers sometimes can't get these instruction by these tutors. So we think what we can do for this in this teaching process that we have uh, decided to uh, visually show these pitch contours to help the teachers and these trainees to clearly uh, to show their singing problems. So as you can see here, Jingju music contains some special intonation characteristics. So compare here, the Hindustani is also the research project in the comp music project. So as you can see in Jingju, this steady singing segment contains more variation, but in this transitory part, the Hindustani contains more ornament. So although there's some pitch contour segmentation algorithm that has been developed for Hindustani, so we want to uh, develop an special algorithm for Jingju. So our research object is the pitch contour of two row types is Laoshen and Dan. And our research goal is to automatically segment the pitch contour into three categories of these vocal expressions. And I will show you firstly this web prototype we have developed. So let me introduce this web prototype of these training tools. So this is the interface of this web prototype. The first graph here that will show the teacher's demonstrative singing. And the lower one is the pre-recorded students singing. So let's first check the teacher's graph. So on this teacher's graph, you can see several elements. The first one is the pitch track, which has been segmented. When you put the mouse here, and you can see it's a segmented pitch track that's being highlighted. And also you can see this green rectangle, which is these nodes has been segmented by this algorithm. And then the information of the nodes is showed on the right corner, which shows its pitch, its frequency, and its timing. The pitch contour that aligned in the students graph will also be highlighted. And it's the same for the node segment. So when you click the node segment, you can listen this nodes singing. And when you hold the shift key and click the segment, and you can hear the corresponding notes on the student's graph. And here in this graph, you can select the line you want to practice. So when you change the line, this graph will be also updated. So let's get to the first line. So when you click the play button, and then you can click and hold the record button to record your own voice. 为国家拿火长安. So your voice has been updated. So you can see this node has been segmented, this pitch track has been segmented. Then you can click it to listen, and also to listen to the teacher's version. So to compare. So nextly, I will do this approach. Sorry, I have 5 minutes. Okay. So this approach is basically given the Jingju Sing recordings, and we will first do the preliminary segmentation to get these node pitch contours. Then we apply thresholding to get the final segmentation. Then we use KN classified to classify these pitch segments into these three categories. And for these others, we do a new round segmentation to segment it back to this linear trend. And finally, we do this refinement. And for this first step, we do a node transcription, and we use a modified peeing, a node tracking algorithm, but we use an estimated bigram node transition probability from a Jingju Sing score data set. It's because these original peeing is use empirical and this kind of probabilities, so which is not adapt to this Jingju case. So for this second one, we use this called the standard deviation of the cumulative difference of local extrema to get this final segmentation. So, and for this criterion value is lower than the threshold, and we put the segmentation point on that. And then we do this pitch contour classification to segment the pitch contour into three categories. And for these first linear trend categories, it contains the steady segment and the transitory one. And we use the KN classify because it's a simplicity. And in this table, there are the features. So with this, the final step for this algorithm is we do a refinement to eliminate this over segmentation. So it's basically to join the adjacent pitch contours if they both satisfy these certain conditions. So for this evaluation, we have this data set, and we have the grand truth annotation for this each node transcription and the pitch contour segmentation. And these metrics to evaluate this algorithm, which contains the node transcription, it's the correctness on this onset and the offset timing, and also we will evaluate the pitch accuracy. So this result shows for the node transcription, our modified peeing, it has a slightly increased performance than this original one. And for the pitch contour segmentation, we choose this baseline algorithm is an Hindustani pitch contour segmentation algorithm. So as we can see, our proposed algorithm is outperforms. So the contribution, we have incorporated this bigram node transition probability, then the estimate from Jingju scored data set. And we have a pitch contour segmentation algorithm. And we have also a web prototype. And for this feature work, because our teachers is paid much attention on this syllable and each phoneme pronunciation. So the feature works will concentrate on this segmentation.